Hello, we are on 5.03 today, and today we're going to be talking about points of concurrency, which is a lot of vocabulary and some memorization with that as well. So we're going to start off with a table with just our term, and then we're going to draw, just going to make a table here, your term, and usually lets me touch there. And then we'll draw a picture. And then we're going to write the point of concurrency and where it occurs. So the term, and then picture. Then we're going to write what is the point of concurrency. Now concurrency just means where the lines meet. So it's a point where all the lines would meet at a single point. And the location of that point. All right, so let's start with perpendicular bisectors. Bisector. Okay, so we've talked about a perpendicular bisector before. We're talking about it inside of a triangle now. So perpendicular bisector, by definition, is a line perpendicular to a side of the triangle at its midpoint, at the midpoint of that side. So really important to remember that. It also is the only special line that we're going to talk about that is not coming from a vertex. Only one not from a vertex. So it does not have to go through a vertex. So if we have a triangle, let's make it a right triangle here. And then I draw in my perpendicular bisectors. So I would find the midpoint of this side and then draw a perpendicular line through there. I would find the midpoint of this side and draw a perpendicular line through there. And then I would find the midpoint of this side and draw a perpendicular line through there. So you'll notice when you have a right triangle, our point of concurrency actually lies right on the triangle. This point of concurrency, so that green point that I just circled there, the blue point that I circled in green, that is called your circumcenter. So that's the part where you have to memorize. So you need to know perpendicular bisectors meet at a point called the circumcenter. And the circumcenter, you can see it's on the circle here if it's a right triangle. And now I'm going to pull up this little applet here. So you've got a triangle here, and I just want you to see what's going to happen. So as we take this orange dot, which I'm just going to have it play actually, I think. It was working. Let me just put my mouse on there. Okay, so if we take this orange dot and we move it, so here we have an acute triangle. So all three angles A, B, and C are all less than 90. It's inside where the three lines meet. So they've drawn in the perpendicular bisector of each side, and those are those pink lines. So as I move my vertex and make it into an obtuse triangle, where do the three lines meet? Well, now they meet outside of the triangle. And if we make it a right triangle, just like we did in our picture, it's going to be right on one of the sides of the triangle. So the location of this point is if it's different depending on what kind of triangle. So if it's an acute triangle, it'll be inside. If it's a right triangle, it's going to be on the triangle. And if it's an obtuse triangle, so it has one angle bigger than 90, it's actually going to occur outside the triangle. And if you are unsure ever, you could always kind of draw out a picture like we did here. It might not always be exact, but you'll get a pretty good idea of where it's going to fall. Okay, next we're going to talk about angle bisectors. So angle bisectors we've talked about before. They just bisect each of the three angles. So if I take this angle and I draw an angle bisector, it splits it into two congruent parts. Then I will take another one and I'll bisect this angle. So I split that one into two congruent parts. And then I'll do the same thing here, draw my angle bisector, and you'll see they meet at a single point, and that one is called the in-center. So here's your in-center. You'll see we have an acute triangle here, and if I, doesn't like my stylus, if I make the triangle obtuse, those three angle bisectors still will intersect inside. And if I make it look close to being a right triangle here, then it still meets inside. So no matter what, and kind of it makes sense if you visualize your angle bisectors, they're never going to go outside of your triangle. You don't have to have perpendicular lines like we did before. They're always going to go through those angles, so they'll always be inside. Okay, next we're going to do the median. So medians of a triangle are drawn from a vertex to the midpoint, median, middle, of the opposite side. So let's look at triangle here. So if I draw in a median, it goes from a vertex. The side across from that is over here. So I find the midpoint of that side and connect them. Here I have a vertex. Here's the midpoint of the side across from it, and then I connect them. And then here is my vertex, my third vertex, the midpoint of the side across from that, and connect them. So you see here, that point right there is our point of concurrency. So it's where all three lines meet. That one is called the centroid. I always remember as like median, think like meteorite, centroid. That's how I remember. All right, let's look at your centroid now. So for your centroid, if we have an acute triangle, you can see here all three lines have been drawn. This is what it was doing before, so it moved for me. And if I make it into an obtuse triangle, those lines are all still going to stay and be concurrent right inside of the triangle. And then if I make a right triangle, it's still going to be inside. So again, this one is always inside the triangle. And the last one we're going to talk about is an altitude. So you probably think of altitude, you're thinking height, and it is drawn from a vertex and is perpendicular to the opposite side. So this one is sometimes confused with perpendicular bisectors because they are both perpendicular. So there are some similarities in the fact that they're both perpendicular, but this one, altitude, must be drawn from a vertex, where per bisector, it can pass through a vertex, but it doesn't have to. And a lot of times it's not going to, because it has to also pass through the midpoint and be perpendicular. Where this one has to be drawn from a vertex and be perpendicular to the opposite side. So for this one, if you are going, let's start with this vertex over here. If I want to drop a perpendicular to the opposite side, so it has to be drawn from a vertex perpendicular to the side across from it. So the side across from it is over here. So if I drop a perpendicular from this point to this line, it needs to go straight down. Well, that line doesn't happen over here, so you'd have to extend it and then drop your perpendicular. So an altitude can occur outside of the triangle. All right, so let's draw the other ones here from the vertex, perpendicular to the side across from it. So that one's just going to go that direction, but I want to extend that further to a straight line. It should be pretty straight. And then the last one would be from here, perpendicular to that side. Right here. So again, that one is outside of the triangle. So when you have an obtuse triangle, your altitude, depending on the side you choose, could be outside of the triangle. So this point right here is where they meet. That one is called our orthocenter. So as you can see, it can happen outside of the triangle, but let's take a look here again at one of these little pictures. So take our dot. So here is an acute triangle. You'll see that all three altitudes are drawn inside. They are concurrent inside of the triangle. Now, if I go obtuse like I drew before, just so you can see here, two of the altitudes are completely outside of the triangle and one is inside, but they are concurrent at a point outside of the triangle. And then if we make this into a right triangle, they meet right on the triangle, because now your orange line is actually on top of one of the sides of the triangles because it's drawn from a vertex perpendicular to the opposite side. Well, that side is perpendicular to the other side because it's a right triangle. And same thing when you're drawn from B to side AC, that one also the altitude would be on top of the triangle. So just like with our circumcenter, here, if it is an acute triangle, it's inside, right, it's on, and if it's obtuse, then they would meet outside. So one way we remember that is the two lines that deal with being perpendicular. Those are the two where if it's acute, it's inside. If it's right, it's on. And if it's obtuse, it's outside. So the two lines that deal with perpendicular. So again, that is perpendicular bisectors and altitudes. Both include perpendicular lines, so both of them are going to be acute inside, right on, obtuse outside. And then it's really important, so you need to know all of these four terms, how they're drawn, be able to draw them in a triangle, and where they meet. So this is the part where you need to memorize. Perpendicular bisectors meet at the circumcenter. What's also special about this one is if you were to draw a circle around your triangle, so circumscribe it, then the circumcenter would be the center of that circumscribed triangle. For angle bisectors, those are going to be, that point is equidistant from the three sides, but angle bisectors you need to memorize is the in-center. Think it's always inside, in-center. Medians, meteorite, centroid, centroid. They just go together. And altitude is your orthocenter. Okay. All right. So those are ones that you guys need to really, really study. So now I'm going to draw a diagram for you that I want you to copy down. So this is triangle DBF. That's C, C. Those two segments are congruent. That's perpendicular. Those two angles are congruent. Obviously, this is not drawn to scale. They're not all straight lines, but close. So you get the idea. What I want you guys to do is name each of these lines. So I want you to name a line that is an angle bisector. Then I want you to name a line that is a median based off of what we just talked about. Then I want you to name a line that is a perpendicular bisector. And then an altitude. Okay, so pause the video here and find me one line for each of those. All right, so hopefully an angle bisector, you notice this one is bisecting the angle, so that segment would be segment BE. For a median, you're looking to find a line that's drawn from a vertex to the midpoint of the opposite side. So E is here, it looks like it could be a midpoint, but it's not marked, so we can't assume that. But here we have these two markings to show that CB and DC are equal in length, which means C must be the midpoint. So where is there a line connecting that midpoint to the opposite vertex? And that's this line right here. So that is segment FC. For your perpendicular bisector, remember that's the only one that does not need to go through a vertex. And perpendicular bisector must be perpendicular and bisect the side. So that's going to be right here. We have a line perpendicular and bisecting. So that line is, I didn't give you a letter here. That's A. So that would be ray CA. And then our altitude is drawn from a vertex and is perpendicular to the opposite side. So that would be right here, your segment DG. All right, so again, make sure you know that angle bisectors meet at a point. All three are concurrent at a point called the incenter. The medians meet at the centroid, and that's the one we're going to focus on mostly for the rest of the lesson, talking about the median rule, which we call the 2/3 rule. Perpendicular bisectors meet at the circumcenter, and the altitudes meet at the orthocenter. So good idea to make some quick flashcards to study these terms. And also, again, make sure you know bisectors are just perpendicular at the midpoint. Angle bisectors bisect the angle. The medians go from a vertex to the midpoint of the opposite side, and the altitude goes from the vertex and is perpendicular to the opposite side. All right, so again, we're going to focus on the centroid now. So the centroid rule, our special fact, is that the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so that's your special fact about a centroid. So what that means is this centroid itself, so if here's your triangle, medians meet at the centroid, and a median is drawn from a midpoint to the vertex of the the vertex to the midpoint of the opposite side. So here, if we have, here's our midpoint, draw in my, so here's my centroid right here. So that centroid, if I'm looking along this median right here, the centroid is 2/3 the distance from the vertex to the midpoint. So from this whole segment, that's 2/3 of the way if you start at the vertex. Here, this median, the centroid is 2/3 of the way along from the vertex along that segment. So that's our 2/3 rule. So it divides it up into some ratios. So number 1, given the diagram, which I'm going to draw for you, and D, E, and F are midpoints of segment AC, BC, and AB respectively. Remember, respectively just means in that same order. So D is the midpoint of AC, E of BC. And determine the ratio for each of the following. Determine the ratios. Okay, so, we're running out of space. So our picture here, I'll put the picture on the next page so we have it. So this is A, B, C. It's pretty much that picture that we had above. It just wasn't labeled. So that's F and D, and we'll say this centroid, which is where our 3 medians meet, is called M. So first I want you to find the ratio of MC to FM. So I'm looking at MC is right here to FM is right here. So again, our 2/3 rule means that the centroid is 2/3 the distance from C to F. So if it's 2/3, that means we break it up into 2 parts here and 1 part afterwards. So from MC should be double the length of FM. So if you always memorize here that MC is 2x and FM is 1x, the bottom part's the 1x, the top part's the 2x, that will be really helpful. So that tells us that it's in a ratio of 2 to 1. I'm going to give you a few more to try. AB to ME, BM to MD, BD to BM, and FC to FM. Pause the video and see if you can try to write all of those ratios out. All right, so we've got AM over here to ME over here. So again, this is from the vertex is your 2x, this is your 1x. So AM to ME again would be a ratio of 2 to 1. Next is BM right here to MD, which is right here. So BM, again, same thing, is your 2x. This part is the bottom part to the midpoint would be your 1x, so that would also be a ratio of 2 to 1. BD to BM, so BD is the entire segment as ratio of that to BM. Well, if this is 2x and this is 1x, the whole thing is 3x if I add them together. So that would be 3 to BM, which is 2x, so a ratio of 3 to 2. All right, and if you weren't able to do those on your own, pause the video here, see if you can try FC to FM on your own now. All right, so FC to FM, FC should have been 3, and FM would be 1, so it's a ratio of 3 to 1. Now those ratios are really going to help now that once we're going to apply some values here. So M is the centroid. So here's where it's important that you know that medians meet at the centroid. So sometimes they might tell you these are all medians. Sometimes they might say, here's the centroid, like I am right here. WX equals 21. Find WM. So your picture is O, W, R, goes to x, y, and z. So let's label. So we know wx is 21, so that's this whole thing is 21. Again, I know from the vertex to the centroid is 2x, and then from the centroid to the midpoint is 1x. So now I'm just going to take those 2x plus 1x and set them equal to 21. So I get 3x equals 21, divide by 3, I get x equals 7. So oh, I didn't put the m in there, sorry about that. M is the centroid of WOR. So if I want to now find WM, don't just leave it as x equals 7. Make sure you answer the question. So WM is my 2x, so I would just do 2 times 7 to get 14. Is your WM. Okay, let's try another one. This time Y is the centroid. Again, centroid is where what meets? The medians. If TY equals 8, find YW and TW. Here's your picture, TUV. And obviously not drawn to scale, but all straight lines. All right, and they meet at Y. Okay, pause the video here, try label it, and see if you can do this one on your own. So TY is 8. We want to find WY and TW, the whole thing. So again, I'm going to label this as my 2x. So from the vertex to the centroid is 2x and 1x. So this one, I'm given the length of TY, which I called my 2x. So I could say 2x must equal 8. Divide by 2, x equals 4. So now if I know this is 8, this must be 4. Again, from the centroid to the vertex is double the lower half of your median. So we know x is 4, which means YW is 4. And TW is the whole thing, so you would just add 8 and 4 to get 12. And we're going to do another part B for that one, so using that same picture. So if YZ equals 9, find UY and ZU. So again, you're using the same picture. Okay, so let me switch to purple here. So YZ is over here. So that's 9. I know that's the bottom part of my median, so that would be my X. Actually, if you didn't already, pause the video and try to do this one on your own. So this is my 2x. So if this bottom part is 9, this top part is double that. So 9 times 2 would give me 18. And then ZU is the length of the whole thing. So we got 18 is 2x, 9 was our 1x, so 18 plus 9 would give us 27. All right, and we'll do one more. O is the centroid of triangle CAT. If LT equals 6, find OT and LO. And here's your picture. So O is the centroid, triangle CAT, L, P, and M. Okay, pause the video and solve this one. All right, so this time you were given the length of the whole thing was 6, and you want to find OT and LO. So again, you can label them as your 2x and your x. Set up your equation, so you'd have 3x equals 6. So you get x equals 2. So OT is 2 times 2, so that would give you your 4. And LO would just be your 2. All right, and that's it. So again, a lot of studying you guys have to do, knowing those 4 terms. Perp bisectors meet at the circumcenter, angle bisectors at the incenter, medians at the centroid, and altitude at the orthocenter. Study, study, study. If you have any questions, be sure to let me know. And pi out.